value is bigger than 1, well, that means that I'm taking whatever I was and I'm increasing its size. So it's getting bigger. Let's spell some stuff right here. Okay, so I'm getting bigger when C is bigger than 1. And what if C is less than 1? Well, if C is between 0 and 1, then this is going to be a compression. It's causing everything to sort of shrink its size down to something much smaller. Okay? Now, notice these things just take into account what happens when C is greater than 1 or less than 1. Okay? No negative values come in here yet. We're not worrying about negatives. We're just looking at what happens when the number we're multiplying is positive and then in the various locations. All right, horizontal shifting, horizontal scaling. Well, just like horizontal stuff earlier dealt with things on the input side. Same thing with the scaling. Horizontal scaling, again, takes place to the inputs in a similar way. Y equals F of C times X. This is our horizontal scaling, and it causes our graphs to stretch or compress, again, depending upon the values that we're putting in. All right. So here, if so if C is greater than 1, and this again, it may seem kind of backwards to you. Okay? If C is bigger than 1, well up here when C was bigger than 1, we stretched our graph out. Down here, if C is bigger than 1, this is actually going to cause a horizontal compression to our graph. Okay? All of the input values are now being moved to the left. They're being moved closer in. Okay? And so this is going to cause a compression. And then if C is between 0 and 1, so 0 less than C less than 1, this is actually going to stretch our graph in the horizontal direction. All right. Finally, what happens if the values of C are negative? Negative values, a couple of different things happen. Let's just, for a moment, worry about what happens if C equals negative 1. Okay. That's the important thing. If we can get down what happens if C equals negative 1, then we can sort of, worry about all the rest of the stuff later. So, when the value of C is negative 1, that results in what is called a reflection. Again, depending upon whether we're multiplying on the outside or whether we're multiplying our inputs, is going to give us a different kind of reflection. So let's take a look at our graph of y equals x squared again. And if we look at multiplying y equals x squared by negative 1. So here's our graph of y equals x squared. If I multiply this whole thing by negative 1, what happens to my graph? Up is not the term I would use. I would say it flips, right? It flips down. So instead of opening up like this, the graph of y equals negative x squared looks something like this. This is our y equals negative x squared. What has happened here is that all of our values have become negative. We've flipped our graph, we've reflected it over the y-axis here, or the x-axis. So multiplying this particular function on the outside by negative 1 has reflected our graph now to be on the bottom side. We've reflected it across the x-axis. And that's exactly what happens to any graph when you multiply it on the outside by a -1. So if we look at y equals negative f of x, this is a reflection across the x-axis. Okay? So we reflected that across our x-axis. What about a change on the inside? What if I was to multiply on the inside of this particular function by -1? Okay? So we look at y equals negative x quantity squared. What does that equal? Well, if you do the algebra here and just multiply this out, what do you get? You get x squared again. And in this case, you'd say, well, I haven't changed the graph at all. We've done absolutely nothing to this function by multiplying the inputs by -1. Well, in a sense, you're right. In a sense, you're right. We haven't changed the overall picture of our graph. But that's because this is a special type of function. Okay? This is what's called an even function. We talked about that on Friday. Even functions have this property, that f of negative x equals f of x. But if we were looking at sort of the picture, if we had sort of color-coded our picture to the left-hand side being red and the right-hand side being green, and we applied this negative x on the inside, what it would actually do is it actually switch which side of the graph was green and which side was red. And so, if we take a look at a different function, suppose we take a look at y equals the square root of x. This one will work because it works nice. This graph, for those of you familiar with it, looks something like that. Okay. If I change my input now, if I multiply my x by -1, I get the graph of y equals square root of negative x. What does that graph look like? What's happened to that graph? We've taken this picture over here on the right-hand side, and it has almost the exact same properties. The only difference is that now it opens to the left instead of the right. So the graph of the square root of negative x looks something like that. And so multiplying inside, multiplying the inputs by -1 actually reflects our graph across the y-axis. All right. And that is all. Sorry for going over a little today. That takes us to the end of 1.2. Next time, we will start in on section 1.3, which is all about trigonometry. Have a good day. We'll see you tomorrow.